So in this problem, we have 3 different resistors, and they're connected in series with a 75-volt battery. So we can list what we know. Resistor A is 15 ohms, and resistor B is 20, and then resistor C is 10. And the voltage at the source is 75 volts. And the first thing you're asked to do is solve for the equivalent resistance. So it is 15 plus 20 plus 10 gives us 35 ohms. It is 15 plus 20 plus 10, which gives us 45 ohms. And that's your answer to the first part. The second part asks you what is the current in the circuit. And just like we talked about earlier, as long as we are using information about the entire circuit, we are getting information about the entire circuit. So our current for our whole circuit and for anywhere on that circuit is source divided by equivalent resistance. So 75 divided by 45, and we get that our current is 1.7 amps. Now in this final part, we're asked to solve for the voltage drop on each resistor. So this means we have to talk about each one individually. We have to talk about individual information, not whole circuit. So we won't use source, and we won't use equivalent resistance. We will use individual resistance and total current because the current is the same everywhere. And so what you have to remember about series circuit is the current doesn't change. So for resistor A, we have our equation R equals V over I, and if we want to solve for voltage, then voltage equals R times I. So we'll say voltage equals R, and the resistance of A is 15. And because the current is the same, we'll use 1.7 amps. So the voltage drop in light A is 26 volts. And for B, we have voltage equals resistance times current, and we get that the voltage drop is 34 volts. And C, and remember these resistors can be resistors or just plain resistors, or they could be light bulbs. Those are a type of resistor, times 1.7 amps. The voltage drop here is 17 volts. One thing you should notice is that in a series circuit, the equivalent resistance, the entire circuit's resistance, is found by adding up the individual components' resistance. The source voltage should add up to the individual voltages. So if you add these 3 up, you actually get 77 volts, which is within errors of rounding to our 75. If we wanted it to be closer, we would just not have rounded as much here. If we used the entire number here and didn't round it at all, then we would have gotten exactly 75 when we added up. You don't have to do that, but it's a good idea to double check and make sure it looks reasonable.